All right, ladies and gentlemen, we're still working on exponential equations. Now here, we need to be able to learn to be a little creative. What I mean by that is what happens if one of our bases is somewhere between 0 and 1, so it's a fraction or a decimal. In this case, we want it to actually be a fraction so we can use something. So let's look at example A. We definitely have a base that's between 0 and 1, 1/2. The other side has a base of 4. So what we really want to be able to do is rewrite 1/2 in terms of a whole number. Well, we can actually do that. If we look at 1/2, that's the same thing as 1 over 2 to the first. And anytime I want to move something from the denominator to the numerator, all I have to do is give it, here's my original numerator, a negative to my power. When I do that, let me go ahead and erase and move this over. All right, so when I do that, 1 times anything is just itself, so 1/2 is the same thing as 2 to the negative first power, which means anywhere I see 1/2, I can put that instead, and I see that here, and I was taking that to the x power, and I was setting that equal to 4. Well, I still need like bases, so then I come over here and I realize that 4 can be written as 2 squared, so I'm going to put that in place of 4. Now here, I still got to simplify a little bit, and I have 2 to the negative first times x. Well, power to power rule says I multiply that negative 1 and x. That's going to give me 2 to the negative x, and that's going to be equal to 2 squared. So really, what I'm solving, since my bases are now the same, is the opposite of x is equal to 2, and the opposite of x is, in this case, is negative 2. Now the math behind that is there's actually a 1 right here. So that negative is actually negative 1. So if I divide each side by negative 1, I get 2 divided by 1 is 2. And a positive divided by a negative is negative. And we get x equals negative 2. On the next example, again, we've actually got to look at changing both bases, where the first example, we had to change both bases as well. Forgot to point that one out, so I wanted to bring it up. So what I see here is 4 can be written as 2 squared. 64 is a little bit more fun. Here's what I mean. I get 64 as 8 times 8. Then I factor 8s, and I get 2 times 4 is 8. So I do that twice. But since the order of multiplication doesn't matter, I can switch that 2 and the 4 here. And realize that 64 is nothing more than 4 times 2 times 2 times 4. Well, these 2's actually make 4. See, for the first time yet, we didn't actually have to go down to the prime number of 2. So it's nice that I could before, but I don't have to. Now here's how I'm going to use this. Everywhere that I saw 64, which is under 1, I'm actually going to write 4 cubed. So that's the same thing as 1 over 64. Well, to rewrite that so it's just a base 4, I can keep my base and put it to the negative 3 instead of 1 over 4 to the positive third. Now, when I do that, that means I now have an equation that's written as 4x plus 1 is equal to 4 to the negative third. And I have like bases. Since I have like bases, I'm just going to compare the exponents, and then I'm going to solve for my variable. X equals negative 4. So out of all of this, as complicated as it might have looked, I find that x equals -4.